Had a question about number 2934 from the book and from the homework. So in the homework, everyone's number is going to be a little bit different. I'm going to write out just the ones from the book. And so you have this function, negative 1000x is the electric field in the x direction. And we're told we want to find the change in potential to go from 2 points. So the first thing I'm going to do is graph this function. So here's the electric field in the x in units of volts per meter, and here's the x direction in the units of meters. And so I'm going to graph this from 1 to negative 1. And if you look at your function, in this region, it's going to go from 1,000 to negative 1,000 when it does this. And so it'll start somewhere around here, end up over here. And if I did it right, it should go right through the origin. All right, now with my numbers in the book, I'm told I want to go from negative 0.2 to 0.3. So I want to travel from here to here. I want to know what my change in potential is. So looking at this conceptually, which this is admittedly a very tricky one to look at conceptually, all right, if we were to look at the electric field, so this would be just the electric field. It's in the positive direction, very big, and it gets smaller and smaller and smaller and goes to 0. And then it starts pointing in the negative direction, and as you get further out from the origin, it gets larger and larger. All right? And so if we were to kind of make a graph of how this would look like, we know that at this point, electric field points downhill. So here, the slope is decreasing. So slope decrease, and here the slope will be increasing. All right, because again, the electric field points downhill. And so if we were to graph this out, it would look something kind of like this right here. All right, and what we're doing is we're starting at some point right here and going to some point over here, right? So I'm starting at the point negative 0.2 and going to the point 0.3. And again, this will be different depending on what your numbers are. But so my first part, I'm going to be going downhill, and then my second part, I'm going to be going uphill. All right, and so according to this little sketch here, my change in potential should increase. Okay, my potential should be increasing because I'm going further uphill than I was going downhill. Now, to get some numbers here, we can use this guy here. So we used this the other day in class. And so if I swing the VI over, just my change in potential is equal to the negative of the area under the curve. And that would be the area of this triangle and then the area of this triangle. Now to do that, I need to find the heights of these two triangles. And with that, I'll just use my equation here. So EX, so for instance, EX at the point negative 0.2, if I plug in for X negative 0.2, I'm going to get 200 volts per meter. So for this guy, it's 200, but the same thing for the 0.3, I get negative 300. So that's how I can find my area. And so it's the negative of the area under the curve. Now, the area above the x-axis will be a positive area. Area below will be negative area. So it's 1/2, 0.2. I'm using absolute values here because I know that first area has to be positive. So in this, I should be careful. There's a meters in here and a volts per meter in here. So those cancel to give you volts. And then negative 1/2, 0.3 meters times 300 volts. And so altogether, if you do this, it's a negative 25 volts. Again, with the numbers that I was using. And so when the negative sign cancels, I get positive 25 volts. So we were correct. So like I started here, went up to here, and so overall, even though I went down initially, I do go up. And so that's why you have these two areas canceling out. Okay, because one of the areas means you're going down to some point, and you go up, but the going up part is bigger. Okay, and as usual, there's different ways to do that, but I think that's the way that how I would approach that one.